Hi guys, in the previous video lessons we went over calorimetry. In today's video lesson we will talk about Hess's law and do a problem related to it. Now first, what is Hess's law? Hess's law is the enthalpy change of a physical or a chemical process, and it depends only on the initial and the final conditions of the process. So if we want to find out the enthalpy change of a given reaction, we do not have to worry about what were the intermediate reactions energy. Therefore, the intermediate reactions energy can be used to find out what is the enthalpy change of the reaction. Let's do it and then we will understand it better. Let's read the question first. Carbon monoxide can react with hydrogen to produce methane and water vapor as given in the following reaction. So this is carbon monoxide, this is hydrogen. So carbon monoxide reacts with hydrogen to give methane, which is CH4, and water vapor. Water with gaseous state is called water vapor. Given the following equations, use Hess's law to determine the enthalpy of the reaction. So you're given the first reaction, H2 gaseous reacts with half oxygen, gives you water. Another reaction is carbon monoxide reacts with half oxygen, gives you carbon dioxide. And the final reaction is carbon monoxide reacts with hydrogen to give you methane and carbon dioxide. We're given three reactions, and these three reactions are intermediate reactions. When they give you any reactions that you have to use to calculate the enthalpy of a reaction, and this is our given reaction for which we are looking the enthalpy. So this reaction is formed from these three intermediate steps. Now what do we have to do is, all we have to do is just look at what are your reactants. Our reactants are carbon monoxide and hydrogen. Out of these three reactions, which one contain carbon monoxide? So carbon monoxide is contained in the second and the third reaction, and which reaction contains hydrogen is the first reaction. So in order to form this reaction, we just need to make sure that the number of moles here, so here we have 1 mole of carbon monoxide, here we have 1 mole of carbon monoxide, here we have 2 moles of carbon monoxide. So we see that we just need 1 mole of carbon monoxide, but in the intermediate reactions, we're given two reactions where we have carbon monoxide. Then I look at hydrogens. I need 3 hydrogens on the reactant side, whereas in the intermediate reaction, first reaction has 1 hydrogen on the reactant side, third reaction has 2 hydrogens on the reactant side. From here, I get an idea that since no other reaction has hydrogen, if I add reaction number 1 and reaction number 3, I would be able to add 1 hydrogen molecule with 2 hydrogen molecule. Always remember, when we add the reactions, the left side get added to the left side and the right side get added to the right side. So let's proceed with this step first. So our first step is add reactions 1 and 2. So always remember, what happens with the reaction, the same thing happens with the delta H's as well. So when I add reaction number 1 and reaction number 3, how does it look like? I would have H2, I'm not writing any states, half O2 plus 2 carbon monoxide plus 2 hydrogen gives us H2O plus CH4 plus CO2. When I add these up, I can add my like terms. H2 plus 2H2 gives me 3H2 plus half O2 plus 2 carbon monoxide gives me water plus methane plus carbon dioxide. Now, as I told you, what we do with the reaction, because we added reaction number 1 and reaction number 2, we do the same thing with their delta H's as well. So I'm going to add the delta H's of the first reaction on the third reaction. So let me write it down as delta H1, delta H2, and delta H3. So all I'm doing is I'm going to add delta H1 plus delta H2. So this is negative 241.8 plus negative 247.1, and this would give me 488.9 units per kilojoules. That would stay the same. So this is going to be the delta H for this particular reaction. So here I can write down this delta H, which is the sum total of delta H1 and delta H3. So here comes the sum total of delta H1 and 3. Let's call this reaction as reaction number 4. So we can call this delta H as delta H4, and we can change it here as well, and we can write on delta H4, which is this value. Then next, now we just look at reaction number 4, which is this reaction, and this is the reaction that we have not used. First of all, we will look at our parent reaction. This is our parent reaction that we need to form. Now, in order to get this parent reaction, we would see that we need carbon monoxide. We just need one carbon monoxide. We have two carbon monoxides in this fourth reaction. We need three hydrogen molecules, and we have three hydrogen molecules. So this criteria is fulfilled. We have two, we need one. That means we need to take away one. Then on the left side, we do not have any oxygen. Here we have an oxygen, so we need to get rid of this oxygen. Next, on the right side, we have methane, and we have methane here. We have water here, we have water here. And then there is no carbon dioxide in the reaction, whereas we have carbon dioxide here. So what are we going to do is, we need to get rid of this oxygen, we need to get rid of this carbon dioxide, and we need to get rid of one carbon monoxide. Now, we would see that this is present in the second reaction. We have one carbon monoxide that we want to get rid of from the fourth reaction. We have half oxygen that we want to get rid of in the fourth reaction, and we have a carbon dioxide that we want to get rid of. If we add second reaction in the fourth reaction, what's going to happen is that when we add the left side to left side, we would be able to not get rid, instead we would be able to get a sum of. So if we add second and the fourth reaction, we would not be able to get rid of what we want to get rid of. So getting rid of means subtraction. Now here we get an idea that why don't we subtract fourth in the second reaction? So we would put in subtract 4 and second reaction. When we do that, we're going to put in 3H2 plus half O2 plus 2CO minus carbon monoxide minus half O2 gives us water plus methane plus carbon dioxide minus the carbon dioxide that we get from the second reaction. And now the like terms get subtracted. So negative half, positive half O2, we have 2CO minus 1CO gives us the final reaction as 3 hydrogen plus 2 carbon monoxide. This is what we are left with. This is what we are left with. 2 minus 1 is 2 minus 1 is 1 carbon monoxide gives us water plus methane. Now, how did we get this? By subtracting fourth in the second reaction. Whatever happens to the reaction, the same thing happens to their delta H's. So all we're going to be doing is delta H4 minus delta H2. My delta H2 is negative 283 and my delta H4 is 488.9. This is a negative because this was a negative sign there. So I forgot it to put there, so make sure you remember that. So delta H4 is negative 488.9 minus delta H2 was negative 283. When we put this on the calculator, we would be able to get negative 488.9 plus 283, which is equal to negative 205.9 kilojoules. So the final reaction with the final delta H is negative 205.9 kilojoules. That's what we can put here as. So this is how we use Hess's law in order to solve for delta H. Always remember, here we did not get a chance to multiply anything. Let's say we had to multiply any reaction with a number, then always remember your delta H also has to be multiplied. So whatever happens to your reaction, the same thing happens to your delta H value of the reaction.